Right, make sure to, hit that subscribe and like button. Yeah. Okay.
Have you got any subscribers?
Yeah, I have like two. My wife, might be one of those.
You subscribe to?
I don't like it. Like my wife was like, she's like, oh, I'm gonna look it up, and then she did. And she started playing it, and I don't like. I'm like, no, I don't like watching it.
Wait, just give me one minute. What is it?
Whatever. So that'll be good for y'all, but I'm probably not gonna watch them. Okay, so what we did on lesson 1.1, chapter 1 was some basic intro stuff, categorical versus quantitative, and then we did categorical graphing. So bar chart, segmented bar chart, tables, and pie charts. I think that's all. So what we're going to do on lesson 1.2, it's just one lesson, and it's quantitative graphs and interpreting them. So there's a little more into them. Then 1.3 on Tuesday will be some more stuff on interpreting quantitative data. Because quantitative has a little more in it. Since it's numerical, we can do more averages and standard deviations and ranges and different stuff. So all we're gonna do today is some graphs for them. So what did I write? Stem plot, histogram, dot plot, and then interpreting them. We're gonna use this little acronym, SOCV. I used to do SOCs. So if you look on the back wall, it says how to interpret data, and there's one that says SOCS. But they've now kind of been using, instead of S for spread, they use V for variability. That's kind of a more mathematical term for it, but we're gonna do that. Okay, so we gotta do this first. On this one, it's gonna be more of a lesson where we're just gonna walk through it together more than doing it on your own. A lot of it is just we'll just talk through it. Okay, how many pairs of shoes do we own? So we do need to make this. So I guess let's think about it. I need to think about it because I'll add my data. So in your head right now, think about it. Maybe write it on your piece of paper so that when I ask you, you can think about it. So I'm gonna get my number in my head. How many shoes? Whichever one you want to do. Any shoes. Sport shoe, flip flop, work shoe. Any shoe.
I do sports.
Even shoes I'm thinking of shoes in my closets I haven't worn in a long time.
Yeah,
So I'm thinking. Okay, let me see. I'm gonna do. I guess I'm gonna follow what I have on here. Females. I'm gonna make my list down here. So I'm just gonna answer this one for us. Oh no. There we go. Okay. We're quantitative data. I'm gonna write number 1 down here. So males are you gonna use a green marker? So I was at 10 in my head. No. I'm gonna say maybe 11. I mean, I got flip flops and stuff, and dress shoes and work shoes and different things, golf shoes. Okay. All right. Let's go. Y'all look like y'all already over here. Caitlin, let me see. You're a red. You're a female.
I'm just gonna say 7.
Okay. Oh, that was
I'll
a weird
probably
sound.
say like 10.
10. Okay. Let's go,
I'll
Aaron.
say
12. Okay. Caleb. 9.
28.
9. I mean, by the time, soccer cleats and stuff. Yeah.
23.
What?
23.
All right.
8. 15.
I'd say like 32
Okay.
probably.
32.
Yeah.
All
right.
I mean, I can see how they can accumulate. 14.
Plus I have 2 older
All right.
sisters.
Grant,
Like,
let's get you
seven.
since I got the All right. Can you beat 32? All right. It's okay. These are rough estimates, 22? 3? Efficient. All right. Sweet. This would be great. And let me see. I also know that my dad, I'm making this stuff up by the way. My dad has,
Are you just trying to get?
yeah, I'm trying to get a little better for the boys here. So this is what I'm gonna have to do. In the other class, I think there's also only like 1 or 2 or something like that. My brother he has a lot more than me. I'm gonna say he has like 18. And then my uncle has,
89.
he probably has, you know, like a nice 7. I think he's like, you know, pretty, like he's efficient. My father-in-law, oh, he's got a lot of work shoes. He does a lot of different stuff. I'm gonna say like, I don't know, 15, 16. Let's go with 50. I'm just making stuff up. Okay, that'll be fine. I just needed to add a few more boy, so that we're not just way different. Let's get a little same. Okay. Sweet. So, let's put this into Staplet. So, I would like one of you at your, you know, little groups to go to Staplet and look along with me. So, I'm gonna leave this up here so you can write this down real quick. Oh wait, yeah, we need to go Staplet and look at the graph. So, one of y'all have it, and then I'm gonna have it up here too, but I'm gonna need someone to help me with my numbers because I just lost it. Okay, so we're gonna do a single group right now. We're not carrying male versus female. Right now, we're just putting it in for the entire class plus my brother, dad, uncle, and father-in-law. Yeah, so we're just gonna do one quantitative variable single group. So we're not splitting into groups yet. Okay, so this is shoes. And then I've got raw data. So let's see. What was, all right, someone, or did you have who wrote it down where I can come over here and like, just. For the recording, I did not just touch a piece of paper that a student gave me. Okay, I did not just do that. Right. All right. So let me give you a little bit if you're trying to type all that in, get there. So Staplet, it's nice to have it in your own thing. Y'all can play around with the different graphs, looking at them. You don't have to wait for me to change them around. But okay, so yeah, we're gonna draw. So let's draw. We're gonna draw maybe all 3. So draw a dot plot. Leave room. So split your little number 3 section into 3 equal plots in the area. So make a dot plot on question number 3. So on my little paper, I have dot plot. Then we're gonna do stem plot and histogram. So copy it down. It doesn't have to be perfect. Like, I guess those are at 7. And then there's 8, and that's 3, and there's a 9. So, yes, sir.
Can I, or do you have a paper towel?
Paper towel?
Yeah. If not.
I don't. You can go to the register. All right. So copy that dot plot down on the board or from your computer, whichever one. What's that? Oh yeah, because you weren't here. Yeah. Sorry about that. Oh, it's 2 different packets. Ooh. That was 3 packets. Okay. Other plots, but I was like, that's gonna be a beautiful big dot plot, but then your other ones are gonna be tiny somewhere else. All right, so dot plot, just talking about it here. Nice thing about a dot plot is, you know, it's showing us the exact marks for every single person in our class, plus some of my family members that I included. It's showing our label, and then you can space it out whatever way. You could have gone every single tick mark, or you can space it by 5s, something reasonable. And so we got a couple stacks. Dot plots are nice because we can just immediately see where all of them are. If there's kind of some groupings, some clusters together. And yeah, I think y'all are probably very familiar with a dot plot or how that works. So dot plot. I have to take into account every single dot that we're doing. So dot is one person. Okay. We can do stem plot next. Okay, maybe I'll zoom in. Way better. Okay. So stem plot. Have y'all seen a stem plot before? Okay. They're not always the most common choice. Your histograms and dot plots are more common.
I just didn't know what it was called, like I knew what it was.
Yeah. Sometimes it's called a stem and leaf plot.
Yeah.
And I'm sure you have seen them, but like you really see dot plots and histograms like in just real world whatever stuff. So, but stem plots just aren't typically used as much. So point out some keys here. It's basically like lumping. So we have a 0, 1, 2, 3 over here, and this would be our stem. That's in bold over here on the left side. And then our leaf are our data points, and they're the exact number. So instead of a dot, it's like the exact thing grouped up at everything from 0, 0 to 9. So from 0 to 9, this is from 10 to 19. This column or row is from 20 to 29, so on and so forth. So yeah, nice thing about these is that I can see each number. Like the dot plot, I had to, look at my tick marks and say, oh, that was a 7, that was an 8. I can immediately see there's 2 7s, 2 8s. A key thing on a stem plot is the key. So we have to make sure to make a key every time we do a stem plot because, so like this key is 3-2 means 32. So 3, 2, and then the 6. So this one right here is 26. Sometimes, though, I could have had it to where this means 3.2. Or I could even do, if all of my numbers were like thousands, like every single one of them was like 3,000, 3,200. I could make it something else. But these can mean different things every time. Another thing is like when you get into the hundreds, like let's say someone in this class like had 105, I would have, 10, and then it's still only 1. This side of the stem always is only one number. And so if there's 2 over here, 1 over here, well, this could be 10.5, or it could be 105, it could be whatever you label it. But you have to make sure you put a key on it. So, but yeah, the stem part is your first whatever digits you want, and then the leaf part is always just the last digit that you have. So all the way to the right side, far right side number. Another thing about a stem and leaf plot is I guess I can do it from here. You can split stems. So like see how we have a big group at 0 and 1? Maybe I want to split them to where my first 0 stem is from 0 to 4, and then my next 0 is from 5 to 9. So I'm going to split them into 2 groups. And then it makes my data not as clumped, and maybe I can have some better interpretations. If we were still clumped too much, I could even split it into more groups and go from there. Sometimes it's nice, so like it is nice to hear something and I maybe I can't quite tell as much as now I can really see the spread more. Like the dot plot really showed how spread they were. Now this stem plot that's split into two groups is showing that greater spread.
Is it like to see like outliers and stuff too? Like if you do 5 groups and it's like,
Yeah, like if I split it into 5 groups, that 32 is
Like
gonna be
obviously-
way farther away. It's gonna be accurately represented as, like how spread out they are. So if I'm trying to go for something like that, like showing that I can clearly see like, oh yeah, that 26, 28, 32, whatever are getting really far away. Compared to on this one, it was like, oh yeah, that one's not that far. It's like right there. So there's advantages and disadvantages. You can do different ways. You need to know how to read it. So like you're not gonna have to make many stem plots, you're gonna have to interpret them. So knowing if it does look like this and there's multiple zeros and multiple ones, knowing that this means that one means 0 through 4 and this one would be 5 through 9 and stuff like that. Another important note is if I split it into 5 groups, you can see right here there was nothing, and that's okay. I need to put that. So like when I split it that much, if there's no value in there, I still need to put that grouping and just put nothing there because it's showing that gap. Kind of like, let's see. So where are we? Let's say I had someone with like 51. I would still need to write the 4 with nothing. Okay, so it's really important that we still, if my biggest number, I have to write all the other numbers from biggest to smallest and just leave that gap right there. Okay, so stem plot, they're just not as common like dot plots are used, but interpreting, do we know how to interpret? And then the last one is histogram. So let me back up here. So frequency, relative frequency. Okay, we'll just do frequency. So frequency, histogram. So histograms are kind of like a bar chart in that they're grouping stuff together, but categorical can be put into groups. Quantitative data, they're not in groups. So a histogram groups them based upon what range they fall within. So 0 to up to 5, but less than 5. So this would be all the way up to, 4.99 ... This box right here, so like this one over here represents all the shoes that are from 25 to 29.9 whatever, all the way to 30. But then 30 would be grouped into this one. So histograms are a way of just kind of grouping up our quantitative data and giving us some interpretations here. Some notes. So same thing, like I can have some zeros in it. I can make my intervals bigger or smaller based upon how my data is looking. So I could have an interval that's just 2 instead of 5, or I could have a 10. Yeah. So different things. Let's see. So interpreting. One thing I like to do on histograms is they're typically given to you in frequency. So I like to go through and make sure I note for myself how much is in that group. So like there's 1, 5, 5, 3, 1, 2, 1. And so I gave myself a quick count of seeing how much it is and reading some more stuff into it. Okay. So for the most part, especially on like an AP test at the end of the year, you're not gonna have to make, this would be like a multiple choice question where they give you something and interpret it. For our class, I do have you making, like the homeworks, I have you making some of these plots, and I think even on a quiz and a test, you're making some of these. But for the most part, like on an AP test, you're gonna be interpreting them. But I want you to get practice on making them too, just to kind of feel comfortable with them even more. So, going. Okay. So we've seen these. Again, this kind of section of our year has a lot of mixture of stuff we've seen before, but interpreting it in new ways. Okay, so we did that. Describe the distribution of the number of pairs for our class. And I might do number 5 on a different page, so we'll see. Okay, so this is what we're doing. This is our acronym, SOCV. It doesn't make as much sense anymore because it used to be SOCS, SOCS, which that's not really how you spell socks, but at least it made sense to not forget your socks. But now it's SOCV. I don't know. Maybe we can, Sally, I don't know, come up with some acronym like a riddle or something. But SOCV, that's what we need for a full interpretation. So if I was asked to interpret the data from this, I would need to talk about the shape of my data, the outliers in my data, the center of my data, and the variability in my data. So let's come up with what y'all think, what y'all already know. So what is, if I'm trying to describe the shape of this dot plot, stem plot, or histogram, what are some things that we can use to describe the shapes of data? Words.
Would it be like where it's kind of clustered at and like how it's spread?
Okay, yeah, you could talk about clusters. That would be a good one. So yeah, you could talk about clusters. So like there's groupings. That's all a cluster is. I've got a cluster at here, a cluster at there. That's okay. That's pretty good. All right. Any other guesses, words, things? So one thing we like to talk about shape is called symmetric. So is my data symmetric? So symmetric just means it's, if I put it a line in the middle, it could be flipped on either side. So I guess you could even do some pictures for yourself. So this could be a symmetric graph, or like even this one is symmetric, almost. I went a little high on the right side. So anything that's symmetric can kind of go in the middle and see on either side it's the same. All right, other two. Oh wait, 3 more. Uniform data. Does anyone know what uniform data is?
Does that just mean it's like there's 2?
Yeah, it's the same amount of people the whole way. So like 2 people had 4 shoes, 2 people had 5 shoes, 2 people had 6 shoes. So if I was to draw this graph, so when I do a graph like this would be like, here's data, there's not a lot of data, there's data points here. So that would be like as if I had the same amount everywhere. If something was uniform, it would be a flat line if it was uniform. So my little lines are just like me tracing the top of my data. All right. And then the last one, so you've got symmetric, uniform, and then we have 2 different types of skewed data. So we have skewed right and skew left. Right. Does anyone know what these dot plots would look like, or histograms?
Like, it's like bigger on one side.
Nice, yeah. One side is way bigger and one side has a tail. So, the way I like to remember it is skew right would be, so there's, on these things, there's a higher clump of data and then there's a really long tail to one side. So I like to think about skiing, snow skiing. Like I'm on the top of the mountain and I would ski to the right. So if I'm skew right, I have a lot of data over here, and then I don't have a lot of data to the right. So if I was to trace the tops of it, it would look something like that, where here I am on the slopes, killing it, and I'm skiing down that way to the right. Okay, it just fits in my head this way. Doesn't mean you have to do it. So skew right, the tail is to the right, and then skew left is the opposite. I don't have a lot of data, and then all of a sudden I really do have a lot on this other side. So to draw the tops of it would look something like that. And here I am at the top, skiing down left. Okay. Looking good. Nice little pictures. Love drawing good doodles in class. Great thing. Okay, symmetric, uniform, skew right, skew left. And you can also, inside of these, you can talk about clusters or groups and say there's a lot of data over here and here. There's 2 clusters of data or whatever. Okay. Let's just give a general thought on outliers, but I'm not going to focus too much on it. What is an outlier? We're going to talk about the mathematical way to do it tomorrow. No, Tuesday. So what's an outlier in a data set?
Not part of their pattern.
Not part of the pattern? Yeah, like, I would just say, like, simply data. I'll just really go simple. Data far away from others. We'll even go that. That's not the best definition ever, but it's okay. So if I have a data point, so maybe not data, it's like a point or 2. It's not a lot. Because if there was a lot far away, then it's not an outlier because there's a lot over there with it. So it's like 1 or 2 points that are really outside of the mix here. So if I was to go back, maybe we should go back on our pictures on both of these too. So if I was to go back on our dot plot or our histogram or that. So let's look at our dot plot. What is our distribution? What's our shape looking like? Yeah, I could maybe make a case for skewed right. At this point, it's kind of hard because the dot plot is pretty far away. What about with like my histogram? That one is like, okay, it's either leaning skewed right or it's about to be almost symmetric. Like it's almost in the middle. So stem plot is kind of the same thing, I think. Oh, we need to talk about this too. So stem plot, here's my stem plot, and when it's going to the right, like for talking about skewed or symmetric, I need to like tilt my head and look at it as if my paper is going here is left to right, sort of thing. Okay, so looking at this type of data, yeah, it's in between, and this is the thing with statistics. We're not perfectly symmetric or perfectly skewed right. So the way we want to describe these things is, if you're running out of room, that's okay. I'm just going to maybe put it over here, something like that. Find some room. If I was to describe this, it's not like perfectly symmetric, perfectly uniform, perfectly skewed right. So I want to use like words like it's fairly, approximately, roughly. Did I already say that one? So like something like you're almost symmetric. You're roughly skewed right. I'm going to go with skewed right on that data. It looked like we had more to the right side. So I'm going to say fairly skewed tell me, convince me that you think it's symmetric enough, then maybe you can get the right answer. But okay, outliers. If I was to look at my data, does it look like we have any outliers? Like we have some data that's way out there, but nothing like too far, I think. I don't think, I would say there's no outlier on that. Because like even this 32 has these points coming out to it. Okay, center. How do I describe the center of something? These
Where the
you-
majority is.
What's up?
Where the majority is?
Okay, what's a math term for where the majority is?
Median.
Okay, that's one. Median. We don't like mode in math, but mean. We don't like mode in stat. Not in math. We don't like mode.
I was like, isn't that a math
We don't like mode. So median and mean is what I'm gonna go with. So the median is gather up all your data points in a row, find the exact middle when you cross them off. Mean is the average. Add up all your data points, divide by the total. There's your mean. Okay, let me see. We've got some room on our paper. I want you to make. Actually, let's talk about variability, and then we're going to talk about mean and median. So variability or spread. So what's a type of spread of data? Think along terms of these. Like what's mean, median, mode. Keep going in your math brain. Range, yeah, range. Range would be a type of spread. So variability just means how spread out is our data. So variability, like how spread out is data, basically. Again, that's not probably what you're gonna find in some textbook, but that's what I'll say. So variability is range. It's something, so we've got standard deviation. And we've got IQR. Have y'all heard of IQR? Probably, if you were an IB, you'll probably skim through everything in stats quickly. They might have skimmed stuff. So we're going to actually talk through the next couple days, or not a couple days, it's actually one day. On Tuesday, we're going to go through how to find outliers, go through our means and medians, and go through our standard deviations and IQRs. So this bottom side is like our Tuesday lesson, basically. But let's talk about, since we have a lot of time today, I want to talk about median and mean and when to use them. So another thing to note, the range is a single number, not an interval. So I think our biggest number was at 32, right? 32 minus 3 is not our range, right? Our range is 29. That's just a mistake, and there's been plenty of multiple choice questions on AP tests giving you an answer choice like this or like this. So make sure to do the number, not the interval. Okay, so let's talk about when to use median and mean, and it's related to the shape of our data. So we're not going to write that much in number 5, so you can write this in number 5 at the bottom of your notes if you'd like. So when to use mean. Actually, do I want to do it this way? Yeah, let's do it this way. Okay. When to use mean, when to use median. And so it coincides with what type of distribution do you have? What's the shape of your distribution? Okay. So I'm going to draw some pictures. I'm gonna do that symmetric one that I did. So So those are a bunch of dots in there. That's me doing it until y'all get used to me just drawing the curve. Alright, so if I have perfectly symmetric data, the mean should be right on that like reflection point. It should be right in the middle. So there's the mean. Okay, and if I have perfectly symmetric data, the funny thing is that the median should be directly right there too. It should be the same thing. There's the median. Okay. Let me do the same thing for a uniform data set. Okay, so it's actually the same thing. If I am perfectly, now we're not always perfect, we're actually probably never perfectly uniform. We could be roughly uniform, but it would be directly in the middle would be both my mean and my median. Does that make sense, Swan? That believable? It's not just, I need to convince you. So on both of those, on symmetric, so symmetric and uniform data, there's my mean and median. Okay, let me get to skewed data, or we could just go clustered, but let's do skewed. So let's do a skewed right. Okay. Alright. So on skewed right data, where would our, let's do our median. So our median on this, if I went through all these little dots and found that middle dot, once I crossed off all the other ones, the median, I don't know, I made it pretty thick so I can give myself some room. I'm gonna think the median's somewhere over there, right? Because by the time I cross off these outliers over here to the right, I'm still gonna be over in this pile of dots to the left. So my median shifts really to my bulk of my data. My average though, so let's say we're doing like the average salary, a skewed right data is the average salary of like people in the US. You've got a lot of people over here in a certain range that's more low, and then all of a sudden you've got Jeff Bezos way over here at like billion, trillion dollars, whatever. So this is skewed right. When I add in Jeff Bezos's $2 billion a year, it is Jeff, right? Is that right? Is that the right man? The Amazon man? Okay.
Yeah.
When I add in his billion to my little peon number, my average goes way up. So what happens when I skew data is the mean gets pulled to those outliers. That's not a good thing. Like, which one is better representative of where the bulk of my data is?
The median.
It's the median. Let's go up here. Like, which one is easier to find though, mean or median? I would argue for a large number of data, it'd be the mean. If I had to line up all my raw data in order and then cross off all those numbers to get the median, it would be the mean. So what we're gonna do for these, for symmetric and uniform data, I want you to use the mean, and that's what the AP test tells you to do, so don't just do it because I'm saying it. We're going to use the mean, the average, but on skewed data, anything that's not symmetric and stuff, I need to use that median. That's a more accurate representation of the population. So you can even see this in stat stuff or in the news, like you're watching the news or something. If they're giving you the average, even the average income level of people in US, if they're telling you the average, that's a bloated number. It should be the median or whatever. You can do the same for skewed left data. The mean would be over here, and then here's the median. So we want to use that median for skewed numbers. All right, sweet. Wow, we doing? Oh, we're doing great. Okay, actually, I probably could hurry up. Which of these three types do you prefer? I'm just gonna, I kind of talk through the positives and negatives of the dots. So number 5, you know, like on a dot plot, sometimes it's nice to see all the little dots spread out, but a histogram is nice for big data. Don't worry too much about when to use one or the other. Just know how to interpret them, okay? So I'm going to skip through number 5. Number 6, how do the number of pairs of shoes and females compare? Okay, I forgot our numbers, so.
For females or males?
Yeah, so what were our female numbers?
7,
7.
10, 12, 28, 23,
What?
23,
Oh, 23. Y'all don't have to rewrite these two.
8, 15, 32, 26, 22, and 3.
Okay, and then there's like 11.
14, 10, 9, 8, 18, 7,
What was the last one?
15.
Okay. Alright. Sweet. Those are it. You don't necessarily have to write those again. But I want to put these into Staplet. Yeah. So I want to make them, put them into Staplet. So I'm going to come here. I'm going to go back to Staplet. And with this one, we are going to use one quantitative variable multiple groups. Because if you click on the 2 quantitative variables, it wants explanatory and response, and that kind of gets into least squares regression line, which I'm not wanting to do. So we're going to be multiple groups. That's the Staplet for us. So like this would be shoes, and I have females and males. Okay. Now we're gonna All right, sweet. Okay, so our little thing tells us to graph side by side dot plots, stem plots, histograms. Let's do the main one I want to focus on is the stem plots that are side by side. So let's graph that one. The dot plots were 2 different dot plots that are just, you make a dot plot that's labeled females, you make another dot plot labeled males. Pretty straightforward. Same for histogram. Histogram, we make one histogram. The key is on the histogram, make them the same, the boxes are the same interval. You can't change it. So 1 for females, 1 for males. But stem plot, okay. I'm going to split into 2 groups. So maybe y'all could even draw it that way. Okay, so here's my stem plot for comparing 2 different groups. Okay, so I want to focus on this one because it's just interesting, you know, they've got the stem here in the middle, and then you leaf out to the left and the right. Again, they posted our key for us, so that's super important. So yeah, we have the number 3, 7, 8, 10, 12, 15, 16, 22, 23, 28, 32. And it's just a little different looking at it when it's to the left side, and then we have one to the right side. Specifically, it's weird when we talk about what's the shape of that data. So we'll get to it. So copy that down. Other thing I I didn't like, my wife in like even the little moments. I know I do it, but I use so many filler words, I hate it. You just can't stop using them, like so and whatever. It's just annoying every time I say it. Stop, Matt, stop. Hear like a high school English teacher telling me in a speech, no, stop. Okay, let's see. Number 9 is, maybe I'll just do it on here so that I don't have to flip back and forth. So number 9 says, at least I hope it's still the same. I think I printed something a little different. Yep. So compare the distributions of the number of pairs of shoes between males and females. And so we want to compare them. It's not always going to tell you to make sure to address the shape, outliers, center, and variability. Sometimes, like soon enough, it's just going to say compare the distributions. And so anytime it asks you to talk about a graph, use socks or whatever. So we're going to go through those. You can even bullet point it. You can say like this is okay on a rubric on an AP test. They said this is great. So another thing, so we want to do sock V, and then we also want to add context to our sentences. At least one sentence needs to have context. The example here is that the context is talking about males and females number of shoes. Okay, so if they're reading, if all they had was the graph and my interpretation of it, could they know that we were looking at males and females number of shoes? Or is this the number of like people in your extended family, or like, so we need to make sure to put context into it. So you can even do it exactly like this. You can put shape, and then we're gonna say something about shape. When we're comparing, we want to use comparison words, like the shapes were roughly equal, they were different, the males were greater than females, the females were this and the males were this, stuff like that. So the shape, what are we thinking about the shape of our males? It might be kind of hard to, maybe this might be weird with the dot plot, it's going to be all over my stuff, yep. So maybe the dot plot or histogram is easier to see the shape. What do we think about the males? Skewed right. Now I'm almost convinced that we're like symmetric, or I think we're more roughly symmetric than we are skewed now. On the males, at least. I may even be convinced on the females. So, because of that split happening, it almost like evened out things. It's kind of weird. But we were so close on the first one to saying roughly, fairly, skewed right. But I'm going to say, I think this shape, I'm going to say the males. So I typically like to take care of the context in the first thing, and then you don't have to list it anymore. So I'm going to say the males, number of shoes.
Teachers and students, pardon this interruption, but we need to make an important announcement. Sorry to do this the second week of school, but we are going to need to implement what we call a perimeter seal. This is different from a lockdown. It is not a lockdown. But what we need for everybody to do is to stay in the building. If you've got to go to fine arts, don't cut across the parking lot. Stay within the confines of the courtyard and use the breezeway to get there. And make sure that we're not going out across the parking lot to get to the field house. If you need to go anywhere else, come to an office and we'll help you out with that. Perimeter seals, we're going to move everybody into the building. We're going to keep our exterior doors locked, as we always do. And we don't need anybody that exits, and only known people will be able to enter, and we're continuing as normal. So everything's proceeding, just don't need anybody exiting out of the building at this time. Thank you.
So I wonder what it is.
I don't know, are they just, that doesn't mean that's, something's going on, it might just be that they're not sure, they see some weird stuff or something. That could be
Going
anything.
on.
That could be like, I remember, so my uncle used to work at Magnolia High School, and there's like a freeway pass near their thing, and a mom was like, there's a car parked on it, and it's weird, I don't want, like, something's happening, and it was just a car that like broke down. So, something could be happening, or something like that, or someone with COVID outside the school is COVID. Could be anything. But we're okay in here, don't worry, we're fine. Alright, so, here's my important thing I did. I didn't really grammatically say that very nicely at all, but there's my context. There's my context. So, I got a check mark on that. I'm going to take care of that quickly, so that then I know on my rubric for grading, I'm going to take care of that for an answer. Okay, so I'm going to say it's roughly symmetric. What do y'all think about the females?
I think it's pretty symmetric.
Yeah, I guess I would also say that it might be roughly symmetric. You could say it could be skewed right, there's not enough data. Either way, so technically I should have said, if we were thinking that they were both roughly symmetric, I could have just gone up here and said the males and females number of shoes of distributions are both roughly symmetric. But I didn't do that. So now I'll just say the females was also roughly symmetric. Okay? Sweet, yeah.
Are we allowed to use like the hashtags or do we have to like run it out?
You can use the hashtag, yeah. The pound symbol. Alright, what was the next one? Outliers. So, on here, we either need to set, now that we took care of context, we can simply just say there was one outlier of females. There were no outliers in either. There was 2 outliers here, 1 outlier there.
So they all have to be complete sentences?
They do not. So because of that, we can just say like no outliers if we don't think that there are any. So like I think I'm still convinced that there's no outliers in either distribution. Just because the females, they were close enough, 28, 23, stuff like that. So what I'm going to say is no outliers. Okay, and that's done. I did it. That's good. Just like that. What's the next one? Center. And then we also need variability. So we haven't quite, talked as much about these. So the center, actually, the really nice thing about this Staplet, I scoot down and through my writing, it says the mean of the females, the mean of the males, the median. It gives me everything I need. So we said that we're roughly symmetric. So the mean and median are supposed to be about the same, right? Which they are. So that's like me. They're not perfectly symmetric, but they're pretty close. They're only like 1 number away each. So that's just proving my point before, that if it's roughly symmetric, if it's perfectly symmetric, those are going to be equal. If it's roughly, they're going to be close. So for the center, since we said symmetric, we have to use mean. So I'm going to come down here and say, what was it? Like 16 and an 11 or 11.5?
Yeah.
Okay. So what I'm going to say is I'm going to compare the two. So I'm going to say the females have a greater number of shoes, 16. So let me just start writing it. So females have a greater number of shoes. And then the way I did that, I'll just say it. I'll put parentheses 16. You could also say the females have 16 shoes, which is greater than the males' 11.5. Either way. So the females have a greater number of shoes, 16, than males, and I'll put parentheses 11.5.
Would we put like,
Oh, I need to put the mean, don't I? Have a greater number of shoes, mean of 16, mean of 11.5. Yes. My
and
bad.
then say mean, not like average?
You can put average.
Oh.
Yeah, you can put average. Alright, so I took care of the shape. The shapes are the same. There's no outliers. The females have a bigger number of shoes, and the spread So what's my female range? It's,
32,
what did we say, it was 29. And then the males are 11? Is that right? 7 to 18? I think that's right. So the males have a range of 11 because it's 18 to 7. The females have a range of 32 to 3, which is 29. So I'm going to do the same thing. I'm going to say that you can either go the males have a shorter range than females, or the females have a greater range than males. You can go either direction. So females, maybe I can even do it like this. Females are more spread out than males. And I can put range like females equals 29, males equals 11, and that's perfect. That's a full answer. So the key things on comparing is say that they're equal or roughly equal, say that they're greater than or less than, talk about the context, talked about these 4 things, and that's a complete answer. So it's always one of the other. They're either about the same or one of them's bigger. So what that means is then it's telling me that like females are a little more spread out, but there's the center of them. It seems like we could maybe guess that in general, if we would wanted to guess to the whole entire population, maybe females typically have more shoes than males, but also I made up some data points, so maybe that's false. But our distributions were the same, so now we've got a full and complete answer. Sound good? Yes. Yeah, you can go to the bathroom. So, if you're trying to do this, you've got, see I said so. You also need to like say, shut up when I say so. So, stem plot, oh I even did it right before then. Stem plot, histogram, dot plot. Knowing how to interpret and make each of them, and then doing this right here. Shape, outlier, center, spread with context.
Sorry, teachers, for the interruption. I just want to there's been some questions, so I wanted everybody to be on the same page.
Alright, we're good for notes, by the way, so y'all can put them up.
Stay on campus. Nobody will be leaving, so hybrid students, you will need to stay on campus until we are cleared.
I mean, no hybrid students.
How about maybe they're gonna like you
They're
do,
talking about renewal class, but like,
Release kids, I'm not trying to stay here.
I thought they're gonna come on the announcements, say, you know what, most of will online for these.
yeah.